Next definition, Fourier sine transform or infinite Fourier sine transformation. Definition: the infinite Fourier sine transform of f of x, where x lies between 0 to infinite, is defined by f s suffix s of f of x, which is equal to f bar of suffix x, f bar of suffix s of p, which is equal to square root of 2 divided by pi integral 0 to infinite f of x sin px dx. The function f of x is called inverse Fourier sine transform of f s bar of p. That is, f of x is equal to f s inverse, capital F is inverse of f s bar of p. Now we find the inverse, right, inversion formula or inverse theorem of sine transformation, right? Statement: f s bar of p is Fourier sine transform of f of x, and if f of x satisfies the Dirichlet's conditions in every finite interval 0, L, because we are defined in 0 to infinite, right, real line, right, 0 to infinite, and that every finite interval 0 to L1, L1 to L2, like that, right, finite interval, and further f integral 0 to infinite modulus f of x dx is convergent, that is absolute integrable. Then at every point of continuity of f of x which is equal to square root of 2 divided by pi integral 0 to infinite f s bar of p sin px dp. We'll see the proof. We know that Fourier integral formula f of x, which is equal to 1 by 2 pi integral minus infinite to plus infinite d omega integral minus infinite to plus infinite f of v cos omega x minus v dv, which is equal to 1 by 2 pi 2 into integral 0 to infinite d omega. Because d omega, so minus infinite to plus infinite d omega can be written as 2 times integral 0 to infinite d omega. So when you are replacing omega by minus omega, so there will be no change in integral minus infinite to plus infinite d omega. So that is why we are considering it is an even function. So from the property of definite integral, we know 2 times integral 0 to infinite d omega integral minus infinite to plus infinite f of v cos omega x minus v dv. Therefore f of x, which is equal to 2 and 2 cancel 1 by pi integral 0 to infinite d omega integral minus infinite to plus infinite f of v cos omega x multiplying with omega x minus omega v dv. Put omega, which is equal to p, and d omega, which is equal to dp, then there will be no change in the limit as it is, right? So f of x, which is equal to 1 by pi integral 0 to infinite dp integral minus infinite to plus infinite f of v cos px minus pv dv, that is equal to 1 by pi integral 0 to infinite dp integral minus infinite to plus infinite f of v. We are using cos a minus b formula, cos a cos b plus sin a sin b, cos px cos pv plus sin px sin pv into dv, that is equal to 1 by pi integral 0 to infinite dp integral minus infinite to plus infinite f of v cos px cos pv plus f of v sin px sin pv into dv. We are multiplying f of v to both terms. So splitting the integration 1 by pi integral 0 to infinite dp integral minus infinite to plus infinite f of v cos px cos pv dv plus second integration 1 by pi integral 0 to infinite dp integral minus infinite to plus infinite f of v sin px sin pv dv, which is equal to 1 by pi integral 0 to infinite. So we are taking cos px to the first one. So we are grouping cos px into dp, that is one integration, and another one integral minus infinite to plus infinite, the remaining one f of v cos pv dv, plus similarly the second term 1 by pi integral 0 to infinite cos px dp integral minus infinite to plus infinity f of v sin pv dv. So f of x which is equal to 1 by pi integral 0 to infinite cos px dp integral minus infinite to plus infinite f of x cos px dx. Just we are changing the variable. Instead of v we are putting x. There will be no change in the integration, right? That is minus in integral minus infinite to plus infinite f of x cos px dx plus 1 by pi. Similarly the second one also integral 0 to infinite sin px dp integral minus infinite to plus infinite f of x sin px dx. That is equation number 1. Let us take f of x is an odd function in the other part minus infinite to 0, that is the negative side of the real line. So since cos px is an even function, f of x is odd function, so product of even function and odd function you will get odd function. So f of x cos px is an odd function. We know from the properties of definite integral minus infinite to plus infinite an odd function value into dx which is equal to 0. Here f of x cos px dx which is equal to 0. Since sin px is an odd function, f of x is an odd function, so f of x sin px is an even function. Product of two odd function you will get even function. So from the properties of definite integral, so integral minus infinite to plus infinite even function can be written as 2 times integral 0 to infinite, right? So integral minus infinite to plus infinite f of x sin px dx which is equal to 2 times integral 0 to infinite f of x sin px dx. So 1 implies f of x which is equal to 1 by pi integral 0 to infinite cos px dp into that value is 0, right? Plus 1 by pi integral 0 to infinite sin px dp into that can be written as 2 times integral 0 to infinite f of x sin px dx which is equal to 2 divided by pi, right? So first term cancel, so second term 2 is constant, take it outside, 2 divided by pi integral 0 to infinite sin px dp integral 0 to infinite f of x sin px dx. So we are splitting 2 by pi into root of 2 by pi into root of 2 by pi, root a into root a, right? Integral 0 to infinite sin px dp integral 0 to infinite f of x sin px dx. So keeping one root of 2 divided by pi for the first integral 0 to infinite sin px dp and the second root of 2 by pi to the second integral 0 to infinite f of x sin px dx. That is equation number 2. We know that from the definition of Fourier sine transform fs bar of p which is equal to square root of 2 divided by pi integral 0 to infinite f of x sin px dx. So 2 implies f of x which is equal to square root of 2 divided by pi integral 0 to infinite sin px dp. The second term, right, is nothing but fs bar of p. Therefore f of x is equal to square root of 2 divided by pi integral 0 to infinite fs bar of p sin px dp. Fourier sine transform and its inverse also can be defined in the following form. S bar of p which is equal to integral 0 to infinite f of x sin px dx and f of x which is equal to 2 divided by pi integral 0 to infinite f s bar of p sin px dp. Thanks.